All right, hi everyone. I am just making a quick video to give you a few examples for the work that I want you to try today. There are problems where we're continuing to use synthetic division to divide, and we're trying to fully break down our polynomial so that we can get the factors or the zeros and be able to graph it. So they're going to give you a value to divide by. We have to determine if the thing we're dividing by, so this x is a solution, aka does it go in evenly? So we're looking for remainders of 0 today. That is our ultimate goal. So I'm going to try number 50 as an example, and then you can try a few others like that. So here it's asking me to see if negative 4 is a solution. So when I do this, I'm going to set up my synthetic division with negative 4 on the outside, and then the coefficients of my polynomial across the top. So 1, because we skipped x squared, I want a 0 x squared in there. So 0, negative 28, and negative 48. So hopefully we get 0 as a remainder. So I bring down the 1. 1 times negative 4 is negative 4. So that's negative 4 there. That would give me negative 4 times negative 4 would be 16. So negative 12. And positive 48. So we get a remainder of 0. Which means if that happens, then x plus 4 is a factor and negative 4 is a 0, okay? So think about if I started with a cubic function and I divide out an x, what I'm left with is a quadratic function, x squared minus 4x minus 12. And our objective, the second thing they asked us for, is to find all of the remaining factors. So we know we found this 1 over here, x plus 4. We said, hey, that works because I got a remainder of 0. But now I want to use either factoring, quadratic formula, whatever methods I have. Once it's a quadratic, then I can use those options to find the remaining zeros. So this is a quadratic, and I think it's factorable. I need to look for numbers that multiply to negative 12, that add to negative 4. That would be negative 6 and 2. So my remaining factors are x minus 6 and x plus 2. So my fully factored polynomial is x plus 4 times x minus 6 times x plus 2. It's a cubic. We know our end behavior would be down and up. It's odd and positive leading coefficient. Your zeros are negative 4, 6, and 2. So we could plot those on a graph. And then just sketch our cubic polynomial through those points. So you don't have to do the graphing part today, but I'm just sort of showing you where that's leading, okay? So that's the first type. They also might ask you in the next section to verify that the given factors of the function are actually factors. So you're doing the same thing here, x plus 3. You want to synthetic divide by negative 3. And then once you get your answer to that, you're going to do what we call repeated division. So let's maybe do one more of those. We'll try 57. All right. So I'm going to first synthetic divide by the factor x plus 2. So in the box goes negative 2, and then across I have 2, 1, negative 5, and 2. So I'm going to do my synthetic division here, bringing down the first number. 2 times negative 2 is negative 4. Add there, so I get negative 3. Negative 3 times negative 2 is 6. Add and I get 1. 1 times negative 2 is negative 2. So I get, again, a remainder of 0. So, hey, x plus 2 is a factor. And now we're going to do what's called repeated division. So instead of me starting a new problem, I'm going to take my answer here, and that becomes the top row of coefficients for the synthetic division for the next factor. So x minus 1 is what I want to divide by, so I'm going to put a positive 1 out here and do my synthetic division again. So bring down the 2. 2 times 1 is 2. Negative 3 plus 2 is negative 1. Negative 1 times 1 is negative 1. So I get, again, a remainder of 0. So that tells me x minus 1 is also a factor. And then if I started with a cubic function here, after I divide out 1x, I'm left with a quadratic. Oops. And after I do that again, this would just be x to the first, or a linear degree function. So the last factor is 2x minus 1, and the others are x minus 1 and x plus 2, okay? So keep doing, it's called repeated division when you use the answer to do the division again. So that would be a trick to use for the last few problems to try. I did throw an imaginary 0 at you, so just a couple notes that remember I squared is equal to -1. That's important. There's also dividing by a radical here, so remember to treat square roots kind of like when you add and multiply them, they need to have like terms. When you add them, you can multiply anything together, okay? So give the highlighted problems a try. It's due on Wednesday, and we will check in about them then. Have a great day.